Alright, good morning, good afternoon, good evening. Mr. Wahlberg here, section 9.2, which is on theoretical probability. We've been talking about probability, looking at the possibilities of things that you can get, rolling a dice, picking a card, spinning a spinner. As it says here, the ratio of the number of favorable outcomes to the number of possible outcomes. Basically, you're creating a fraction of the favorable outcomes over the possible outcomes. If I roll a die and I want to know what the odds of getting a 3 are, well, there's 6 numbers on a dice, so my odds of getting a 3 would be 1 out of 6. Another idea there is, what's the probability of getting an even number? Well, half of them are even, so it would be 3 out of 6, which of course can reduce down to 1/2. So these are just examples of theoretical probability. Doesn't mean that's exactly what you're going to get, but in theory, half the time I should get an odd number, half the time I should get an even number, and so on and so forth. Alright, it says you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Again, here is my probability of an event. It says the number of favorable outcomes over the possible outcomes. Well, first of all, I'm going to count total 1, 2, 3, 4, 5, 6, 7. There is a total of 7 possible outcomes, and I want to know what's the theory of choosing a vowel. Well, there are 3 vowels here, 1, 2, 3, the red ones, so my probability for favorable outcomes would be 3, and as I said, possible outcomes is 7, so 3 out of 7 is my theoretical probability of choosing a vowel. Next thing, it says theoretical probability that you randomly choose a green marble from a bag is 3/8. There are 40 marbles in the bag. How many are green? Well, they're telling us the probability of 3/8. It says there's 40 in the bag. How many are green? Well, we've done this a lot. Create a proportion which we're trying to solve for the number of greens in the bag. The 40 tells us there's a total of 40 marbles in the bag. 3/8 is the probability of it being green, so I'm going to create a situation where I cross multiply. Cross multiplying 3 times 40, is 120. That equals 8x. When I go ahead and divide by 8 on both sides, x would be 15. So there are 15 green marbles in that bag. Alright, we have a little spinner game here. It says the scoring rules are you get 1 point when the spinner lands on blue or green. Your friend gets 1 point when the spinner lands on red. The first person to get 10 points wins. You and your friend play the game. Is this fair? Well, there's an equal amount of reds, an equal amount of greens, and an equal amount of blues. So each one is 2 out of 6, which is 1/3. So yes, the spinner is fair. However, B says, is the game fair? No, the game's not fair, because you basically have 4 out of the 6, which is 2/3. You have 4 out of the 6, 2/3 of the colors, where your friend, Wade, only gets 1 out of 3, because that would be the 2 out of the 6. So, no, the game is definitely not fair. Let me erase some of this and get to C. C is saying predict the number of turns that it will take you to win. Well, I just said there that our probability for me would be 2/3. So, if 2/3 is my probability of getting either a green or a blue, I'm going to multiply that times x to get a total of 10 points. Now fractions, we got to remember how to do this. I'm going to divide by 2/3 on both sides. These cancel out. I have to then divide 10 divided by 2/3. How do I divide by a fraction? I need to multiply by its reciprocal. Make that a fraction. 10 times 3 is 30. 1 times 2 is 2. 30 divided by 2 gets me 15. So my theoretical probability is saying that it's going to take me 15 turns to win the game, versus obviously the other person that their probability is not very good when it's only 1/3. Okay, last thing. You have a spinner here. I would like you to determine the probability for each thing: spinning gray, spinning a 3, spinning white, and spinning an even number. That's section 9.2 on theoretical probability. We'll see you tomorrow. Thank you.